So I'll start talking with how can we understand intestinal health and how we can quantify intestinal health and their impacts on the productivity in pig production. Okay. All the data I'm going to share today is based on the meta-analysis of the large data that we obtained during the last 5 years in the lab. First of all, I'd like to introduce the very significant people working in the lab together. And Xiangyu Shu is a master student, and Hyunjun Che, Jonathan Baker, Ji-Xiao Deng, Victor Hugo Moita, and Ichi Cheng, and Kibon Zhang, and they are PhD student. And we have Dr. Marcus Duarte, he's a postdoctoral research associate. And the data I'm going to show you is Marcus did a lot of work for doing a statistical analysis of the data. So I highly appreciate him for this work today. If we look at what current issues we have in pig production globally, there can be many, but you may agree that we have a pandemic issue, which greatly affected pig production in last year. And also we cannot ignore these climate changes. Occasionally we have very severe weather conditions which affect the pig production, like hurricane in North Carolina, for example. And in many parts of the world, the HP-free production is an urgent issue, trying to understand how we can do that. People do that well also. And we have a big concern with high increase in the feed cost, especially in very recent days. And these are more specific the issues we have, which is related to the growth performance and the health status of the pigs, which are the intestinal health at the center. And we cannot ignore our interest related to the microbiota, especially gut microbiota. And also this gut disease is causing a lot of issues. So I tried to quantify if that's intestinal health is important in pig production or not. So I had a chance to count the number of papers in the scientific journals, which was working on or investing the intestinal health and gut microbiota in pigs. Also, I compared the number of papers related to the growth performance of pigs as a kind of comparison. And you can see the rapid increase in the number of papers in both topics. But if you look at this black bar showing the number of papers related to intestinal health and gut microbiota, the most of those papers are published since 2010. So earlier times, we didn't have a big interest or understanding about the intestinal health, but it is after 2010 that many of us are highly interested in handling this issue. So as an introduction, I'd like to talk about how we can understand intestinal health and their impact on pigs. And later, I'll move to the data based on the meta-analysis we did. So then why do we need to concern about the intestinal health? That's because our pigs, especially with new living pigs, their intestine is not ready for the weaning the environments, such as the physical separation from the mother and litter mates, and they are moved to the pen with new pigs and causing mixing stress. And also they are fed a solid feed based on the cereal grains and legume seed meals, and they are not used to those. And there are numerous papers showing that new living pigs, they get the intestinal challenges. And also their intestine is not ready for the solid type cereal grain based feed because they are used to digest the components in the mother's milk. And also their intestine is not ready to secrete enough acid for the activation of pepsinogen to pepsin for protein digestion. So we have issues with problems with the low starch digestibility and also low protein digestibility for the new living pigs fed a solid diet based on the grains and legume seed meals. And that will increase the amount of undigested nutrients going to the later part of the intestine and causing the increased the bacterial fermentation. And there's a good evidence showing that that is related to the increase of diarrhea. So that's what we see to the new living pigs upon the weaning when they're fed these solid diets. Okay? Problems with nutrient digestibility, and that will cause the diarrhea. But also, we cannot ignore the components that we provide to the pigs through the feed. And those feed are, very well made, and those nutritionally perfectly balanced. But those feed also contains some components not necessarily good for the new living pigs, like such as allergenic compounds can come from these cereal grains or legume seed meals. They're also known as the anti-nutritional compound. And some of this stuff could be potentially contaminated with toxins, and also those are not sterile feed, and there is a possibility of including numerous pathogenic bacteria in the feed together. So when the pigs are consuming those diets, and these anti-nutritional allergenic compounds, toxins, and pathogenic bacteria will also ingest it together, and that can cause the issues. So if I show you this well-developed, healthy the villi from the genome of the new living pigs, looks like that. And just a few days later, those all the villi could be partially or fully destroyed based on due to the weaning stress. Okay? And then the problems with pigs with destroyed villi structure, they cannot absorb, digest feed and absorb the nutrients, so it will be related to the increased diarrhea as well. So this is what we want. We all of us want our pigs eat. Once they're weaned, they eat well and grow well. But the reality is they often don't eat, and if they eat, they show the diarrhea as well. So here, where should we look at? So how can you understand to solve these issues? So if this is just the entire GI tract of the pigs, my research is mainly focused on what happens in the small intestine rather than the stomach or the large intestine, because small intestine is the major parts responsible for nutrient digestion and absorption. And this is the longest part of the GI tract, and that's where also the increased stress or challenges will be received. Okay, so the main questions we had was, number one, how bad is bad intestinal health? Okay. So then, what are the consequences of bad intestinal health? That was the second question. And third question was, can we quantify intestinal health? We talk about the bad intestinal health a lot, or many times, but they're lacking information of how bad is bad, okay? And can you quantify that? Also, and how much of that bad intestinal health, which can be quantified, will affect the pig production? So that's our the fourth question, the last question. Okay, I'll scroll down this. All right, this is what I think what happens to the pigs. So those pigs are weaned with immature intestine. Okay? They're weaned at 2 to 4 weeks of age, and then they're fed the feeds with very good nutrients, and nutrition-wise is perfectly balanced. However, those feed will include those allergenic compound, toxic compound, and pathogenic bacteria, and so on. So the intestine of this immature intestine of new living pigs will get the challenges. And then they will cause the immune response and started with the inflammatory response in the intestine. And then those activated immune cells will produce massive amount of reactive oxygen species that can cause oxidative stress or oxidative damages to the intestine. I'm talking about the small intestine. And those will together will cause the disintegrity of the gut barrier, causing the intestinal leaking or gut leaking. And then at the same time, those gut leaking can cause the increased pathogenic infection by translocation. And then they will be related to the impaired intestinal structure. So the pig's intestine will lose this nice villi structure. And they will cause the increased proliferation of the cells in the crypt. So we have enterocyte proliferation increased. And all this together will cause the reduction in nutrient digestibility and their absorption into the body through the intestine. And because of all of this, finally, we see that the new living pigs don't grow well, of course, don't eat well and don't grow well. So this is a sequential step that I think what happens to the new living pigs related to the intestinal health. So then, how can we quantify this intestinal health? So this quantification is based on each step I just listed in the previous slide. So sequentially, we have very good ways to measure the inflammatory response. You can quantify pro-inflammatory cytokines or anti-inflammatory cytokines or both. But in my lab, we've been measuring, quantifying TNF-alpha, interleukin-8 and 6 as major cytokines related to the intestinal inflammation. And then for the immune response, you can measure immunoglobulin type A and G as biomarkers for the humoral immune response. And we can measure malondialdehyde, I'll use that as an MDA, and protein carbonyl or 8-hydroxydeoxyguanosine as a biomarkers for indicating the tissue damages from the oxidative stress. And for the gut leaking, as a direct measurement, you can quantify the proteins working for the tight junctions. We call it tight junction proteins. And for the intestinal structure, you can measure villus height, and villus height to crypt depth ratio is very, very commonly done. And what we also do is we measure the crypt cell proliferation by immunohistochemistry, staining the Ki67 proteins in the proliferating cells. And then we also measure ileal digestibility of nutrients. And we also measure the mucosa-associated microbiota, looking at their diversity and relative abundance. So these are our candidates as biomarkers to measure the intestinal health. And all these biomarkers actually are related based on the sequential step of what happens to the new living pigs for their intestinal health. So based on the introduction, I'd like to spend time to show you what we discovered. These are based on the meta-analysis, and all the step work was done by Marcus. Thank you. And I'd like to show you these major outcomes. So what we did was we looked at the studies that we did in the past. And so we collected all the data from at least 35 studies conducted since 2016. But all those studies, they have a uniquely different objective. However, the measurements we did in those studies were very similar. We looked at all those biomarkers using the tissues from the jejunum of the small intestine. And we also collected growth performance data from those pigs. Actually, those the data from individual studies are published. Many of them are published, and these are all the list of them. And from here, we obtain this gut health data and mucosa-associated microbiota data, and we are relating those to the growth performance of that particular pigs. So this is the summary here. So from this more than 35 studies conducted since 2016, we measured this gut health biomarkers from at least 3,000 pigs using the jejunal mucosa, the middle part of the small intestine. And we measured those biomarkers that I listed earlier. And also we measured the mucosa-associated microbiota from little more than 1,000 samples using the jejunal mucosa. And I'd like to show you just a few examples of the outcomes from the meta-analysis we did. So this page shows the inflammatory status in the jejunal tissues of the pigs and their relationship with average daily gain. Okay? So I'm showing you the TNF-alpha. It's one of the pro-inflammatory cytokine as an example here. So these are, if you look at this graph on the left side, those are all the data collected from 35 studies basically. And the y-axis shows the amount of TNF-alpha in the jejunal mucosa. And the x-axis is the average daily gain of those particular pigs that we killed for this analysis. And there are many observations with different color coded that indicates different studies. And you can see the lines. And those are the correlations between or relationship between TNF-alpha and ADG of pigs of individual studies. Okay. So this is the first step we did. So we looked at, some studies we had a linear negative correlations and there's a broken lines and so on. But the next step is the good thing about meta-analysis is you can combine all this information together. And we got this nice, very strong, statistically very strong and very well-fitting equation, which is shown to happen to be the broken lines. Right? Two linear lines are together. So this line is expressed in this equation. And p-values were so low with very high R-squares and other fitness measurements. And here, what it says is when a pig has TNF-alpha in their jejunal tissue, and if that amount is 0.84 picogram per milligram of protein in the jejunal mucosa, then if the number is greater than 8.4, probably up to 1.5 or even higher, then, which is shown in this section of the graph here, the average daily gain of that pigs will gradually decrease. Okay? So that's basically, it makes sense. If pigs has a inflammatory response or inflammation in their intestine, they will not eat well and they don't grow well. So that is shown in this part of the graph. There's a negative correlations between TNF-alpha and the ADG of pigs. Okay? That happened until TNF-alpha was as low as 0.84 picogram per milligram of protein in the jejunal tissue. However, if pigs maintained TNF-alpha level smaller than 0.84 picogram of milligram of protein in the jejunal tissue, then their ADG did not further reduce. So it was plateaued, maintained the same. So this can be one. This can provide one important information to show the relationship between the intestinal TNF-alpha level and the ADG of the piglets. And we repeated same thing for every daily feed intake or gain to feed ratio, feed efficiency. And we also looked at other biomarkers such as protein carbonyl, or malondialdehyde, or immunoglobulin A, immunoglobulin G, and so on. So from all those meta-analysis, we obtained highly significant correlation equations, regressions between the biomarkers and the growth performance of the pigs. Okay. Probably I don't have to mention go details for each one here, but we are continuing to look at the relationship between the specific mucus-associated microbiota to the growth performance of pigs, but also we are also looking at the interaction between among or between the biomarkers themselves. Okay? So it's still ongoing. It's ongoing work, but then our ultimate goal is to do this. So if you have access to a farm, okay, we get the representing samples, probably like 10 pigs or 20 pigs from the very large farm, and we take the intestinal samples and we bring it to the lab to the quick assay, ELISA or array, to generate the level of biomarkers, and they're using the pre-obtained the models that we had based on meta-analysis, we can predict their growth performance. Okay? And then we can do key risk factor analysis to find out which biomarker is giving more trouble to that particular farm. And then we can think about what could be the solution or how can we help the farm to handle those issues with its intestinal health. And then it goes back to the farm. We are trying to solve those issues, and then we can do continuous monitoring of the intestinal health of the farms. Then I think we can maintain the efficient pig production with maintaining good intestinal health status. Okay. So as a conclusion, I can say the intestinal health is measurable by quantifying the biomarkers that I showed you in these examples. And then we can also measure their relationship with the growth performance of pigs. And I listed again the key biomarkers that we measured in our lab. And I'd like to say the intestinal health biomarkers can be used to determine the farm productivity, and also you can use them to validate the efficacy of some nutritional manipulation to enhance the farm productivity. All right, so that's all I have, and this is virtual presentation, but I'll try to receive your questions and